time, I would like to invite Professor Chris Fegan. Chris has been consultant hematologist in Wales since 2005, and he's got a long-standing clinical research interest in CLL. Just to mention a few, particularly in apoptosis, new drug therapy, and telomeres, which he's leading on. He's also chairing quite an important, he's a director of research and development in Cardiff, also chairman of Hematology National Strategy Advisory Group in Wales, and helping Leukemia Cares. Thank you, Chris.
Thank you, Renata. Hello, everyone. Just so I get a feel for the audience, who's actually a patient or patient representative? Lovely. Can I apologise to all you, because you understand CLL, we have to dumb this down for the scientists, because they just work with it, you live with it. And I'd also like to thank the speakers. The title says, What We Don't Know About CLL. Thank God they've only given me 25 minutes, because I could talk for days about what I don't know about it, but they're going to save my blushes. They've only given me 25 minutes to squeeze some things in. And of course, the question is, what do we still need to learn, and what's the current gaps in our knowledge and care? I'm going to touch more on those sort of things as we go along. Of course, what is research? This is what we do. If you want to know anything in life, go to a military man. Somebody with real power at their fingertips, literally. And what is research? What it's trying to do, there's known knowns, things we know we know. Then there's known unknowns, things we know we don't know. And of course, then there's the unknown unknowns, things I've not even thought of. I've thought of a few of them after a few too many drinks, but by the morning I've usually forgotten what the hell they were. So it couldn't have been that good an idea. But try and think outside the box. So we're going to talk about, to start with, some of the things which we would regard as known knowns. Things we think we know about CLL. But do we really? But let's actually get started. Well, we do know that CLL gets more common with age. I think we'll accept that. Yep? Good. We do know that there seems to be differences in different ethnic groups around the world. It seems to be more of an Anglo-Saxon, Caucasian disease rather than people of a black origin, and the Asian Pacific appear to have lower incidence than Europeans as well. But is that an economic thing? Most patients are found by chance. In the Western world, we do irrelevant bloods all the time. It's the way the GP getting you out the room quicker. You palm them off with a full blood count. Costs £3, that gets them out the room quick. So is it really true? And is these other parts of the world develop and get a more westernised lifestyle? God forbid they get the obesity problem that we have. But are we going to see the CLL change the pattern? We just don't know. We're at one moment in time, really, as CLL. But it's very interesting. And of course, like everything in life, men get it worse than women. Yeah, that only having one X chromosome for some reason holds us back. You need two to be a proper person, it appears. But it's a bit late for half of us, isn't it? So we have to get do with it. So we know the disease is ageist, racist and sexist. I wonder why I was drawn to it. Anyway, let's move on from there. My counsellor told me not to say that. Anyway, moving on. And of course it's nepotistic, it runs in families. Certain other things run in families. It's nice of this, those who are from overseas may not know that. That's the Duke of Edinburgh. So we're visiting his town, really. It's nice one to share, but that person is married to Her Majesty. He did well for himself there, really well. But CLL is nepotistic. 1 in 20 people actually have a family member with it. And we know that is a fact, and we know a bit more why that may be. But actually, there's other things about CLL. It's a disease that self-harms. It affects your immune system. It switches the immune system against you as a person. So it's got all this ageist, racist, sexist, nepotistic, and self-harmer. It's a wonderful, wonderful disease. I always like this, but actually, well, I'm one of you. Don't listen to her lies. I mean, that could easily be politicians, couldn't it, nowadays? And unfortunately, they determine healthcare around the world, the politicians. So you can't ignore them. And of course, with CLL, what we actually know is the disease itself cannot live without other cells. It's a parasite. It can't live outside the normal environment of those cells around it. That's true of most cancers. We have this idea that cancer is like an exocet missile. You fire it off and away it goes. No, it lives on you. It's an absolute parasite. And eventually, like these people, they bleed you dry. And if you're unfortunate and you can't get that sort of thing off your back, and it's interesting, the cost of treatments now, hey, yeah, it's all coming home to roost. It's a parasitic illness at the end of the day. And it's an addictive illness. It actually has what's called oncogene addiction. We'll talk a bit about that. It has cell survival pathways. There's at least 6 survival pathways in CLL, and it has to have at least one of these switched on. So it's addicted to one of these survival pathways, or it just can't carry on. Because the modern addiction, drugs and alcohol, they're old-fashioned now. It's now mobile phones, isn't it? You know, anyone with children, you know, it's absolutely fabulous. They just leave you alone now. They don't pester you unless they need a new game, or they need your credit card so they can buy new things. Football Manager and things like that. Don't let them have your credit card, honestly. You're going to live a long time, patients. Don't let the kids have access to your monies. You're going to need it. They don't. They'll only waste it. And in fact, it's a wandering disease. It's a nomad. It doesn't actually live in one compartment. It lives in 3, in a very different roles. We think the lymphoid tissue is where it gets its signals to proliferate. The cells divide and grow. These other departments may actually just stop it dying, but they don't proliferate in the blood. They probably proliferate in the lymph nodes, spleen, and liver. Doctor Who. So this is really, CLL has been regarded as an old person, grey man's disease. But here's Jodie Whittaker, actually, as the new Doctor Who. I mean, times have changed, haven't they? But actually, Jodie's older than the 2 youngest patients I've seen. I've seen a 23-year-old with CLL, and I've seen a 28-year-old with CLL. And both of these were women. Well, that shouldn't happen. And one of them was Asian. And that shouldn't happen. So we really don't know an awful lot, even about these things which we accept. Actually, we think these are known knowns. But are they really? So let's get on to dodgier territory. The known unknowns. Things we know we don't know. Why do people get CLL? We don't know that. What the hell have you lot done? I was brought up a Catholic. If I'd got CLL, my mother would have said, that's because at the age of 5, and you didn't confess it to the priest, did you? Which is, we don't know why people get CLL. We still don't know the basics. We know why people get lung cancer and a few other cancers we know. But actually, most cancers, we haven't got a clue why people get them. And CLL fits into that. We don't know why people get it. So for those of you who wanted an answer to that, you may as well leave now, because you're not going to get that over the next 4 days. But it may be worth hanging around. There'll be other snippets for you, all being well. Why does it increase with age? Is it an environmental factor? The longer you live, you're more exposed to it? Could be. Is it actually that our own bodies rot as we get a bit older? I'm almost 60, I can say that. Almost. I used to wake at night thinking of scientific things. I now wake at night thinking, am I going to fall asleep before I go to the loo? And run the gauntlet later. I don't know. Times change. Why does CLL increase with age? It is our immune system. We can keep it at bay, but our immune system ages, and that's why we get it later on. We actually don't know really why it increases with age. We'll touch a bit on that. And why more men than women? I know they're blessed. I know they're special. I know they control the purse strings. That's a Catholic thing as well. You handed your wage packet over on a Friday afternoon and she gave you your beer money, if you were lucky. So why do people get CLL? The cell of origin. Which cell does it come from? We know where lung cancer comes from, stomach cancer, breast cancer. We know where. The CLL cell has been really quite a hard thing to find. For such a common cancer, you think actually it would be a very common cell, but it's not. We now agree it's a CD5, CD19 positive cell. These are antigens on the surface. But they're actually quite rare in the human body. So we've got a rare cell getting a common cancer. That's all a bit odd, to me anyway. We do know that actually most of these cells have experienced antigen. If you go back 20 years, the world authorities and some of the great and the good were telling us it's a naive B cell, it doesn't do anything. It's a rather boring disease, actually. We now know that's not true at all. It's a very experienced character indeed. It's experienced antigen, it's experienced protein, so it's not a dull disease at all. But we do know, when we go back to that nepotistic thing, which genes do people inherit that make you prone to CLL? There's a whole host, there's almost 60 now described. So the more you've got of these, the more likely to get CLL, but they're not all equally make you prone. Some will make you 1.1% more likely to get CLL, some will make you 8% more likely to get CLL. But they all add up and they're quite additive. But when you look at these genes, they actually are involved in the immune response. So maybe the immune response is important in developing CLL. This thing called apoptosis, people think that cells just die, they keel over. That's not correct at all. You actively kill yourself as a cell. You switch something on called apoptosis, and here we are in Edinburgh, where it was very first described in 1972 by Wiley and Kerr with the apoptotic process. So we've come home to the truly apoptotic disease. But in CLL, the cells don't die. There's not a lot of evidence that CLL cells grow quicker than normal cells, but it's difficult to measure because we're not quite sure what the normal CD5, CD19 cell is. But if it is growing quicker, it's very marginal. But I'll tell you what, having been born, the little bugger don't die. He hangs about. Do you remember the New Year's Eve party? We embarrassed an uncle on the dance floor who just won't sit down and get out of the way. That's what CLL is. Once on the dance floor, it does not leave. It hangs about forever. But we do know it's related to chromosomal damage and chromosomal repair. We know about the genetic abnormalities involved that make you prone to CLL. These things are at the end of telomeres. These are survival pathways relevant. And this B-cell receptor signaling, we know it can actually feed itself and keep itself alive through BCR signaling. And the BCR signaling implies it's antigen-driven. The cell is finding a protein, it's sticking to it and helping drive the cell. That's important because if we knew what those proteins were, we may actually be able to develop a vaccine to CLL. Why do people get it? So if we look at the acquired genetic abnormalities as opposed to hereditary ones we just talked about, they're in the same pathways. The most common genetic abnormality, 13q, 17, 18, 19% of patients have it, are actually involved with BCL2 anti-apoptotic protein. The 11q23 ATM is DNA damage, BERT3 is a survival pathway with NF-kappa B. Trisomy 12, NOT1, is related to a c-MYC protein, which is a B-cell proliferation agent. So what we're slowly putting together is a picture of what goes wrong with the cell. Not with the individual patient, but with the cells overall. But we're still talking about herds, not individual people. So when people turn and say, why have I got CLL? The answer is we still don't know. It's one of our known unknowns. Why do people get it? I can recommend this review just come out recently from two internationally renowned people. There used to be this idea there was a CLL hematopoietic stem cell. It's a stem cell disorder. The evidence for that was always very weak. It was a good story for some folk, but it really didn't stand the test of time. What we now think happens if this B cell, CD5, CD19 cell, actually reacts to an antigen, and there's a T cell independent, and CLL is a B lymphocyte disorder. We have T lymphocytes, and they work together in your normal immune system. And your T cells help you fight off infection and help you fight off cancer. That's their job. But there's a T cell independent and a T cell dependent. And if you go for the T cell independent experience antigen, you get unmutated VH genes. If you go through the T cell dependent, go through the post-germinal center, and you get mutated VH genes. Why those should be so different in survival isn't clear. Are we talking actually two diseases? Or is it one disease which has just gone through a different survival signal? We still don't know really if it's one disease or two, or dare I say 20. But we're simple folk. Let's deal with one disease first. Try and master one before we try and master 20. But we do know it's not random. These antigens are not random. There's things called stereotyping, that when these antigens actually encounter the B-cell receptor, you can rearrange your immunoglobulin genes. And what comes out is not a random pattern. They're recognizing certain types of proteins. Some of those proteins look like they're from viruses, some of them look like they're from bacteria, and some of them look like they're what's called autoantigens, where your own immune system is attacking yourself. If you think of rheumatoid arthritis, for example. So it looks as if there's triggering of CLL by certain types of antigen. If we knew exactly what they were, we could develop a vaccine for that particular type of CLL. But we don't know what they are yet. We're still working on that. Moving on. Again, back to, it's a common disease. We commonly hear that if you live long enough, every man will get prostate cancer. If we live to 150, probably every bloke will have prostate cancer. Joy of joys at the end of the day. But actually we know that the immune system, the hemopoietic system, ages as well. We know, in fact, that as people get older, you actually develop abnormal hemopoiesis as a normal function. That you can get up to over 10% of your blood is actually abnormal when you get older. If you go up really old, over 100, almost 30% of the cells you're producing are what we would call abnormal. But you haven't got a disease, they're still functioning normally. But if you look as we get older, below the age of 29, virtually nothing happens to you. As we get older, our hemopoietic system actually ceases to be normal. But is that abnormal, or is that just normal for age? Is this part of normality? Why are we the most effective species on the planet? Because somehow we've evolved in a different way to other animals. We haven't got more genes than other animals. We've actually got less genes than a frog. What we have got is better genes. That we rearrange those genes in cleverer ways, maybe to mutate and develop mutations. It's actually what's led to the human race being the most effective, destructive, depending on your term, beast on the planet. Maybe this is normal for our species, of which what is happening in CLL is where this normality turns against you. Another unknown. We have a look. This is for myeloid leukemias. We know they get common as we get old. That's one of the genes there. But there's a couple we're familiar with, TP53, SF3 beta 1. We will find them. If you're over 80, you've got a very high chance of having one of these. I'm rapidly aging that way myself, so I'll find out. So is it normal? We know monoclonal B-cell lymphocytosis, a thing we're familiar with, that actually 12% of healthy adults get it, 1 in 4 over the age of 70. That's a funny cancer, isn't it? Is this actually normal that our normal B cells are undergoing through that same aging process that the rest of us is going through, and it manifests itself in this way? And as I say, is there a role for autoimmunity in driving that on? As our immune system ages, you normally dampen down autoimmune diseases. As our immune system ages, are the autoimmune signals waking up as we're getting that bit more vulnerable, that bit more mature, or knackered, depending on how you've lived your life, all in all. Why more men than women? Well, that's always an intriguing thing. We know women are from Venus and blokes are from another planet, or various planets maybe. I can highly recommend Biology of Sex Difference journal. Always very interesting if you get bored reading about CLL. But in this journal, it came from China, they look at some of those susceptibility genes that you get in CLL, they think make you prone. And in fact, if you look at females, that's a female there, this is talking about methylation status, which is what switches on and off your genes. We've all got the same genes, men and women. Actually, men have got a few more because you have a Y chromosome. You missed out there, ladies, didn't you? You've got two X's. We've all got the same genes, but how we use those genes depends on the methylation status. And there's a female, and there's a bloke. There's a female, and there's a bloke. So very interesting. We have the same genes, but we're using them differently. Well, I know women think that's obvious we're using them differently, but I'm talking about CLL here. That actually the disease profile is different between men and women, and different between patients with CLL and those who have not got CLL. So trying to explain that sex difference, there should be more data comes along in due course. And as now that women do more similar jobs to men, and men do more similar jobs to women, and we're all living longer, will that sex difference actually change over time? We will find out in due course. Anyway, trying to move on. We haven't got all this. So why do some people CLL progress and others do not? This is some of our work with CLL with telomeres. It's just the bit at the end of the chromosomes, the very important bit. Imagine chromosomes are like laces, and that plastic bit at the end, which is designed to stop your laces from fraying, that's your telomere bit. It holds the genome together. If they get shorter, the genome, the genetic material can fail as they get shorter. So here's some work we published before with CLL. The more advanced your CLL, the shorter your telomeres, and the worse you do. But one interesting thing about all this is normal people. And these are normal B lymphocytes. And you see some normal B lymphocytes have very, very, very short telomeres. And some have very, very long. So even in normal people, there's B cells with very short telomeres. Those telomeres will have got short because the cells have divided more. Maybe they're dividing, reacting to an antigen, be it a virus or a bacteria or an autoantigen. So those are shorter, but once you get that genetic abnormality in that cell, then that carries on being bad forever. So your telomeres remain enormously robust over the course of your illness with CLL. It's actually built in at the very, very beginning via your telomeres. Those do not change. So what our data suggests that if you're unfortunate that this is the B cell that gets the genetic insult, you have bad CLL from the word go. If you're up there, then you have a disease which is going to actually be a lot less aggressive than it otherwise would be. Immune function, we know that infection's a big problem in CLL. Lots of patients have trouble with this. There is endless abnormalities described with the normal B cells in CLL, that actually you get low antibody levels, your antibody therapy. Can these all be right? But that's nothing when you actually look at the T lymphocyte, the non-cancerous T cells, which are meant to help. There are endless abnormalities described in CLL in what are meant to be the normal non-cancerous cells. So what is going on there? And it's quite amazing anyone with CLL isn't keeling over from infection. These can't all be important. They've all been described. They can't all be important in reality. And then when you go on top of that and you add therapy in, fludarabine, cyclophosphamide, rituximab, you get even more T-cell dysfunction. So no wonder patients are prone to infection, because actually the T cells, the good guys, are actually not functioning well at all. Why is that? Are the CLL cells turning them off? Are they actually the CLL cell dampening down your own immune system? Or are they reacting to the T cell, to the CLL cells and getting exhausted? Or are they reacting to those antigens that maybe gave you CLL in the first place? They're reacting as well, and therefore not functioning well. Again, I go back to the telomere story. If you actually look, here's your CLL cells from start to end. On an average, that was over 6 years. Your telomeres get shorter by 52 base pairs. The normal is 50 to 80. So in fact, your CLL cells are aging at the same rate as the rest of your body. But your good guys, T cells, are aging over twice as quickly. So somehow, your CLL cells are aiding your immune system. And if you start off with an old immune system, and dare I say, we all have very variable telomere lengths from birth. Women, they wouldn't they, have longer telomere lengths from birth. They come out 18 months younger than a male. So, boys, you may have thought your mother loved you, but she poked you out 18 months older than your sister. This is clever for only a 9 months gestation, but that's mothers for you, very, very clever. Your T cells are older than you are in CLL. So we go to infections. Do we know how to prevent them? Yes. Anna talked about prophylactic antibiotics. There have been virtually no large-scale prophylactic antibiotic studies in CLL patients. We're deriving that idea from other immune disorders, common variable immunodeficiency syndrome. Where are the CLL studies in bacteria? We all know about immunoglobulin, but when you look down, I'd like to show you this, 1988, 1989, 93, 94, and 95 is when all these studies were done. The last randomized studies using different types of intravenous immunoglobulin. Less than 200 patients, and most of these patients were in the pre-fludarabine era. Forget small molecule inhibitors, it's pre-fludarabine. And our practice today is based on that. It's way out of date. It's time we looked at that again. We know that we're not treating infections well enough. We know that patients do not respond well to vaccines. We don't know why they don't respond well, but that's another area we should be looking at. Because again, patients very variable. 50% of patients roughly respond to pneumococcal vaccination. Why that 50% and not the other 50%? Only 15% respond to the flu jab. Why so low? What the hell are we doing about that? We need to find that out. But on the more positive side, are we curing CLL? Here we go. We saw this earlier. FCR, mutated VH gene, long-term survival. Are these patients cured? And I'll just point out, if you look, actually, more important than whether you got the R with the FC is whether you're mutated or unmutated. These patients may well be cured. Yes, they've had quite a toxic therapy, but they may well be cured. But if you look at ibrutinib, that's frontline ibrutinib, that's relapse refractory. Are those patients cured? They may be. We're not quite saying that yet. But also point out, these patients' previous treatment would almost certainly have had chemoimmunotherapy. But the resistant mechanisms we know about ibrutinib shouldn't be relevant on whether you've had previous chemoimmunotherapy. So why the response so different? There's overall, then there's venetoclax rituximab versus BR. Again, can venetoclax rituximab, is that actually curing people? Are these lines flattening off? FGR may well cure, but maybe so can ibrutinib in VR. Overall survival, very similar curves to progression-free survival. So we may already be curing people with CLL. There may be patients out here who've had these treatments today, still living under the cloud of CLL. There's a chance you may be cured. But we can't say that at the moment. But I personally think a lot of you may be. But with my luck in life, I wouldn't put any money on that. Keep your money in your pocket. And what should we be doing? Should we be using ibrutinib before venetoclax? Or should we be using venetoclax before ibrutinib? The schedule. We don't know. Where's the comparative study saying to do that before that or that before that is beneficial? Maybe it doesn't matter which way round you get them. But actually maybe it does. And maybe we should devise in studies to answer that for patients. Almost certainly all patients will end up having both if their disease doesn't respond well enough to the first ones. So why actually are we not looking at which is the best way round? Maybe they're equal, maybe they're not, but we just don't know. The resistance mechanism to new agents I touched on before. Yeah, we know if you fail ibrutinib, 80% will have a mutation we can identify, but it's usually only present in a very minority of cells. So why is the whole disease resistant if only a few of the cells are actually expressing the resistant phenotype? It implies they're not actually the driver-resistant mechanisms. So I'm not sure we do know about how we actually get resistance to these agents. Venetoclax, resistance reported in a patient with only 1.4% of the cells actually had that abnormality. What about the 98% that didn't? All a bit odd. Idealism, we haven't got a clue why people are resistant. There's been nothing at all published. Going on, Richter Syndrome, again, when I can identify differences in patients. Have they got Notch1? Have they had MYC mutation, CDK9, etc.? But if you even look at MYC, 40%, Richter's 40% MYC mutation, what about the 6% who haven't got MYC mutations? We really don't know what the hell happens in Richter Syndrome, is the truth of the matter. And what about, as Anna said, the gold standard cure is allogeneic transplant, where you're using normal T cells to actually get rid of the CLL, from a donor typically. But can we use the patient's own T cells in the CAR-T process to get rid of them? Early results were not encouraging, but there's lots of work gone on since this early data. Can we reignite that aged T cells in a CLL patient, make them younger and fit to do the job, and see off the CLL itself? When should we be using these two modalities? After failing ibrutinib, after failing venetoclax, after failing both? We still don't know really when we should be using these. It's all anecdotal at the moment. And of course, the price of these therapies don't make them easy to do randomized studies if the truth matter to get those answers. And finally, of course, there's things that we've not even ever thought of. So maybe like 20 years ago, and people were saying, the very, very best in the world, it's a naive B cell, it's a bit boring. Maybe in 20 years' time, or maybe sooner, I'll be eating my words yet again. And actually, we'll see it's a completely different thing from what we think it is at the moment. I think we're on the right lines. Only time will tell. All the very best, everyone.